Welcome back to another lecture. And previous time we had already started discussing about what is function and what is domain and range and what all are its properties. And we also discussed about the continuity of function and what it is. So in today's lecture, we would be covering a short yet easy topic which is increasing and decreasing functions. So let's start with it. From the name only, you can understand the function which is increasing is called as an increasing function, and a function which is decreasing is called as a decreasing function. But the question arises that not everywhere you would be given these types of graph where you can exactly find out that is it increasing or is it decreasing or is it constant function. So today we would be discussing in the lecture that how exactly we can find out function or an equation which is given to us is increasing in certain interval or decreasing in certain interval or is constant. So see, first of all, let's start with what exactly a increasing and decreasing function is. So for that, we need to go on to the definition portion that is given in the book. So it says a function f is increasing on an interval. Now it is very important that we always talk about interval. We need to note the certain interval and then only we can answer with respect to the interval that is the function increasing or decreasing or is constant. So it says a function f is increasing on an interval if for any 2 points in the interval a positive change in x results in a positive change in fx. So what it is exactly saying that let us come to the graph and understand the whole thing. Now this function is actually increasing. So it is increasing from this side to this side. Let me just use this marker and come with this. So it is increasing in this pattern. So you know that this graph is having a positive slope from this portion to this portion. It is climbing up. So whenever you are taking out the slope of this function or this graph, you would be getting a positive slope. So this is what it is said that for any two values of your x, you would be getting value of fx. I'm very sorry for the background noise of the pressure cooker. Just ignore that. So it says that for any two values of x, for any two values of x, you would be getting some corresponding y. That is fx. Y is nothing except being fx. So if I take this 1 point and if I take this another point, so I am getting a positive slope, then that means my function is increasing. So this is all what it had said in that point of definition. So this was the definition for increasing function. For decreasing, it is just the opposite. That in the interval, for any 2 points in the interval, a positive change in x results in negative change in fx. That means the slope is negative. So let me just write in short. Here it is concluding to you, and here it is just saying that your slope is telling you nothing. That if your slope is positive, that means your function is increasing in that interval, right? If your slope is positive, then your function is increasing in that interval. Now, the opposite thing would be coming here. That means if your slope is negative, then I just copy paste the thing here and write it to be negative. Okay. So if my slope is negative, then what I'm getting is that my function is now it is decreasing, not increasing. Because my slope is negative, that means my inflection point has arrived. So I told you in the previous lecture that assume that you are having a function which say you it is climbing up and then it started to go down. And when it started to go down, let me call that point as this point is called as x. So my x is an inflection point. Inflection point means a point where the graph changes its curve or changes its increasing property or decreasing property. Like from here to here till x, this function was increasing. Beyond x, this function started to decrease. So my curve became from concave up to concave down. That means it has changed The slope would be zero at this point. The slope is positive in this portion. The slope would be negative in this portion, because for any two x values, if I'm taking on my x-axis, the y-axis which I'm getting is decreasing. That means the fx is decreasing. So I will be getting a negative slope here, and I will be getting a positive slope this side. And this point is called as my inflection point. What point? Inflection point. Inflection point is the point at which your curve changes. That means it becomes from positive to negative or negative to positive. It changes its original trajectory. Now, third is constant. Constant means your slope has to be c. That is a constant value or zero. It is not changing actually. So this is the original definition for increasing and decreasing function. So now let's understand in terms of graphs and more easy things. So the same thing is given here also. If f dash x, now f dash x means first differentiation of x. So now this thing would come into the chapter when you're studying differentiation portion. So then I'll include these things. But here f dash x is the differentiation. And if we talk in layman's language, it is the slope of this function. So if the slope is positive, this function is increasing. If the slope is negative, then this function is decreasing. And if again the slope is increasing, so slope has to be positive. So this is all. And here in this graph, two inflection points are present. First being this one and the second being this one, because the graph has taken the turn from my A point to B point. It is increasing. From B to C point, it is decreasing, and C to D point, it is again increasing. So in some questions, you will get to know that in different intervals, the graph is or the function is behaving differently. So need to always pay attention to those things. So let's move on to example, which is actually saying now this is the same thing which I just told you. Then you need to find out dy by dx, where dy by dx is nothing except being dy by dx is the slope. That means y2 minus y1 is equals to x2 minus x1, or simply it's called as del y. Del y means the change in y upon the change in value of x. So this is exactly what is called as slope of a function. So this you need to find it out, and then we are good to go. Now, graphical representation of the function, this has been shown here. Again, this is the same thing, increasing function, strictly increasing function. We're talking about what's the difference between increasing and strictly increasing, and decreasing and strictly decreasing. In strictly decreasing, basically, the thing changes with less than sign and less than equal to sign. Less than equal to sign, that means if my f dash x, that means the differentiation or my slope is less than equals to zero, then I'm talking about decreasing function. But if I'm talking about my f dash x, that means the first differentiation of that function is strictly less than zero, then I'm talking about strictly decreasing function. So these are the two things which we'll be talking about in our later lectures. But as of now, these graphs were important to understand about how the function is behaving. So let's go on to some questions to understand how the thing is to be done. So see, we are given the question, analyze a function for increasing and decreasing behavior. So I tell you what you need to do in order to find it out, because you can see in the solution, they are just giving you -2 to infinity, minus infinity to -2, then -2 to infinity, decreasing and increasing. But how will you exactly know that at which point it is changing the curve, or at which point we need to take into consideration? Because you cannot put exactly every point into that to find your result. So what you need to do is that as soon as you're given a function, like here we are given that my fx is equivalent to x plus 2 squared. So the first thing you need to do is that I'll tell you what you need to do. That is step one. So step one has to be, why it is Stu1. Step one has to be put your fx, that means put your y equal to 0. This is the first step. So what you are actually going to do, You are just going to put your fx equals to 0. So the moment I do this, what am I getting exactly? The moment I let me just change this to blue so that it's monotonicity is not there in our lecture. So fx equals to 0. The moment we put fx equals to 0, we get x plus 2 squared is equivalent to 0. Now my square, I'm sending it to that side. It will become root of 0 is again 0. So that would be x plus 2 is equivalent to 0. So from this thing, I get to know that my x is equals to minus 2. We had already talked about this in this photo or in this picture. It is clearly written. If you need to find about the inflection points, the points at which your graph is changing, you need to put your slope equivalent to 0. So this was the thing. You need to put your slope equivalent to or the function. Slope equals to 0, function equals to 0. We are putting the function equals to 0 here because we need to find out f dash x. So I'm telling you the shortest method to find it out because you're not aware of f dash x. Because see what will happen in if we just take out the f dash x value here, that would be f first differentiation x, which is twice of that. It means differentiation with respect to x twice of 2x plus 2 equivalent to 0. F dash x has to put equal to 0. So you'll be getting x plus 2 equivalent to 0. And again, you would be getting x equals to 0. So that thing should be done because that is actually giving you how you are getting your answer. So put fx equals to 0 hasn't to be done in exactness. This is to be done only when we're not knowing how to differentiate the function. But we will be learning in forward lectures that how exactly this f dash x is being calculated. So this thing I have got about this thing from that my f dash x is equals to not x is equivalent to this thing. So what I will do, I'll create a number line. These things are important, so you need to just take into account. Put my x value, which is given to you, not 0. My x has, I have calculated it to be 2 minus 2. Okay. So this is my value. Now I need to put some values and find out what is the behavior of my graph in these portions. So let's check. If I put some value less than minus 2 into the main function, if I put value less than 2 into the main function, what I'm actually getting, this is f dash x. If I put some value less than 0, minus 2, that means minus 3. So minus 3 plus 2 is minus 1, which is a negative number. And so on, it has to be given, going. But if you put directly into the function, let's see what is the value which the function is actually giving to us. At my minus 2, I'll be getting 0, y equals to 0. At my minus 3, x equals to minus 3. Minus 3 plus 2 is minus 1. Minus 1 squared is 1. So I'm getting a positive value. Just let me tell you. This is the value of x. This is the value of y. At x equals to minus 2, I am getting y equals to 0. At x equals to minus 3, I am getting a y equals to 1. At x equals to minus 4, I am getting my y equals to 4. At x equals to minus 5, minus 5 plus 2 is 3. That is 9. I'm getting minus 3 and 9 squared. So this is what I'm getting. So if you see here, at my minus 5 value, I am getting some value 9 here. At my minus 4 value, I'm getting some 4 here. At my minus 3 value, I am getting some 1 here. So you can see if you join these points, you're getting that this is approaching to 0 at x equals to minus 2. So you can clearly see that this function is decreasing from minus infinity to minus 2. Now let's check the other way around, that what is happening to the other side of your inflection point. Is it really increasing or what is the result? So if we put minus 2, we are getting again 0. If we put minus 1, we are getting 2 minus 1. If we put 0, we are getting 4. If we put 1, we are getting 9. So these are the values. Now let's plot what is exactly happening here. So I am plotting it for my minus 1. I am getting 1 here. For my, let me take something slighter. For my minus 2, I am getting, not minus 2, I'm sorry, I'll be having a 0 here. So for my 0 here, I'm getting the value of 4 here. For my 1 here, I'm getting the value of 9 here. So my graph is started now to increase, while earlier it was decreasing. So I'll say in the interval of minus 2 to positive infinity, my function is increasing. So this is how you will calculate what is the behavior of the graph. And for that, you need to find it out first, the slope, that is f dash x. I'll be recording another lecture that how is differentiation done of function so that you can calculate f dash x. F dash x is nothing except being del f or df by dx. That means differentiating the function f with respect to x. So this has to be done. And this was the shortcut method by which I told you that how you can find out, because this is fx directly will be giving you what exactly is the behavior. Now gx, let's talk about gx. We need to find what all points are there and then put it equivalent to 0. Now, for differentiating this or finding g dash x, we would be needing the differentiation division formula, that is u upon v thing, and then we would be getting the whole of the answer. So I'll be doing both the methods and telling you how exactly to find out. So now let's check roughly. My gx is equals to x square. I'm sorry, I'll make x like this. So I'm just putting it x square here divided by x square minus 1. Now it is in the form of a square minus b square. So I'll just break it into simplest form, that is x minus 1 and x plus 1, because a square minus b square is equals to a plus b and a minus b. Why I'm writing b here, it should be 1 because my b is 1 actually. So plus 1, this is done. Now I know my denominator can never be equivalent to 0, because at that point what will happen? Not 0. My denominator cannot be equivalent to 0. That means my x cannot be 1. Because the moment you put 1 or minus 1 here, the moment you give value of x equals to minus 1 or plus 1, what you are getting is 1 squared or minus 1 squared is 1. 1 minus 1 is 0. And anything divided by 0 gives you and takes you into infinite world. That means imaginary world at which you are not getting any value. So my function would become undefined at point minus 1 and point 1. So now I'm knowing that there are 2 points, that is minus 1 and 1, where my graph will be changing the position. So what I said to you, put g x equivalent to 0. So the moment I put equivalent to 0, this denominator multiplied by 0 will be 0. I will be left with x square is equals to 0. So I got 3 points, 0, minus 1 and plus 1. Because from denominator, I know these 2 points cannot be there. So I need to exclude them. So if I need to exclude them, I need to take them into consideration. So now let's see the graph which they've already made. I'll mark it up here that what all values are actually being present here. This is the value which is 0. This is minus 1 and this is plus 1. If you see correctly, at point 1, it is tending to infinity, and point minus 1 also, this graph is tending towards positive infinity. This is going up, which clearly implies what I showed you before, that my denominator cannot hold these two values. So it cannot have anything of minus 1 or plus 1 because that is infinite. And between minus 1 and 1 also, I will be having some other value because I got my 0 there, right? So I got 3 points, my minus 1, my 0, and my 1. So I need to check again on the number line that what is exactly the function behavior. So I think I should give you this in homework and find out and run your brains that how this thing is exactly working. See, it is very simple. If you put values less than minus 1 and take out slope of any two values, you'll be knowing and getting like here I what I did. I just started to put the values, and from this thing, I got to know that this is increasing. My y is increasing when my x is increasing. So this is a positive function that is increasing, slope is increasing. Here, my x was increasing, but my y was decreasing. So this is a decreasing function. So this is how you will calculate in this portion also. So I'm giving you this thing in your homework to find it out how exactly thing is being done and run your grades. And then I'll make you solve. Okay. Or let's start only because this is the lecture. Let's just see what is the behavior and how you can exactly find it out. So I'm putting this equivalent my number line here, and with fast forward speed, I'll make my 0 here, I'll make my -1 here, and I'll make my 1 here. Let's start with this point. I'll tell you one very good thing, and then you will understand. Okay, I think I just forgot to mark it up here on the number line that whenever you are making this thing, if one side you are getting positive, other side would have to be negative. So this is just implied thing. So in most of the questions, this is the only thing. So we'll be check for values greater than equals to 1. So the moment we check for the values greater than equals to 1, what we need to do is we need to put it here. So the moment I put my 2 here, let's check. This is my x value, this is my y value. The moment I put values greater than 1, that is 2, I put 2 here, 2 minus 1 and 2 plus 1. So 1 into 3, I get 3 in my denominator. And 2 squared is 4. I'll get a 4 by 3. At my 3, what I'm getting? 3 minus 1, that is 2, and 3 plus 1 is 4. 4 twos are 8. 3 minus 1, 2, 3 plus 1, 4, 4, 2, 8. And above, I'm getting 9 by 8. So now these two values are roughly telling me something. That means for my x increasing, is my y increasing or not? So for that, you just need to use your calculator, or in short, you can just calculate roughly also. 4 by 3 is equivalent to 1.33. Okay. And 9 by 8 is how much? 1.125. 1.125. That means with your x increasing, your y value is decreasing. So if your y value is decreasing, from 2 points, you got to know that your function is decreasing. So what you will do, you will just put a minus sign here. Minus means in this interval, from 1 to infinity, your function is negative. So the moment you do this, you can put plus minus plus here because I told you such thing, right? We can put alternative signs. So let's see whether this thing is correct or not. If I put some value between 0 and 1, 0 and 1, is my function increasing or decreasing? It is decreasing here, and it was doing the opposite thing here. So from this, it is confirmed that not in every function you will be getting a consecutive alternate signs. So you need to always be careful of this thing and just do a cross check whether is this thing applying or not. So what I will do, I'll put some value between 0 and 1, that is 0.5. Let's come here and check with speed at what exactly I am trying to tell you. I'll put some value between 0, that is 1 by 2. So at 0.5, 0.5 minus 1, 0.5 minus 1 would give me a negative value, some negative value. I'm confirmed at 0.5, I'm getting some negative value. So it has to be down the x-axis. That means on negative y side, it has to be there. Now, 0.5 squared is 1 by 2 squared is 1 by 4, that is 0.25. I am getting in upper portion, and below I am getting 0.5, that is 1.5 into 0.5, that is 0.75 something. Yeah, it's 0.75. 0.5 into 1.5, 0.75. Okay. 0.75, and this is negative actually. So when you just do this, you will be getting minus 1 by 3. So this is your first thing which you are getting. It's a negative value. It's just we got one thing. Now put some value which is greater than 1 by 2. So that means I can put what? 0.5 I can put 0.75. So let's do it fast forward. 0.75 into 0.75 will give me 0.525. 0.525. And I need to divide by 0.75, 1.75 into negative of 0.25, that is 0.4375, 0.4375. And again, this below denominator portion is negative. So it is 0.525 divided by negative of 0.4375. I am getting equivalent to 0.08 or something else it was. 0.0875, 0.0875. So this is the thing. And here I was getting 0 point minus 0.3333. So it is clear that this function is decreasing. My y value is decreasing when I am increasing x. So this means this is also negative. So I told you if this is negative, the alternate has to be different sign. So this has to be positive. But will not go like this. We'll always check and put some value and then do this work. So I've explained you for this positive side, you need to do the same thing for the negative side for 0 to minus 1 interval, minus 1 to minus infinity interval, and tell me is the function matching or not. Okay, I'll cover the boundedness topic in the next lecture. Till then, please complete your homework.